It will cover a few questions that were asked during the previous lecture. So for the last half an hour, we'll talk about an interaction between smart contracts and execution environment, meaning both the sandbox and the state transition function. Okay, so just maybe not. Let's start with what does the contract have access to. So during the execution, of course, it has access to the arguments that were passed, right, from the user, and its own storage data that it keeps, right? However, the problem is that having access to just these two pieces of data is very, very limiting. So unfortunately, this makes contracts expression power of contracts very, very limited. Fortunately, there is something like host functions, and this opens our world to limitless possibilities. To understand these possibilities, let's have a quick recap of this blockchain onion. This one. So contracts are executed here in this innermost layer, and we want to open them to the outside world, meaning we want to open them to allow contract to interact with the state transition function, to ask for some things to this layer. Okay, how do we do it? Well, this layer, state transition function, exposes some API, especially for contracts. So a contract can ask its execution environment, who has just called me, what is my account address? How many tokens do I have? What is the current block number? We can ask also for some actions. We want to emit the event. Philip has shown you some snippets. This is emitting events from contracts is done exactly via this API, right? A contract reports a need to emit an event, and it sends this intention to the state transition function. We can transfer some funds outside from our contract to some account. It has to be done with the help of the state transition function. Yes, please.
Mike, thank you. So is the caller equivalent to the message object in Solidity?
I'm sorry?
The caller in the standard API, is it equivalent to the message object in Solidity?
I have no idea.
Message as in like it contains the sender.
A caller will just return an account ID which has directly called our contract.
Gotcha.
So this is that. Also, there is some very simple cryptography that can be outsourced from a contract. So just why? Because computing some heavy operations in the contract, the WASM, will be very expensive in terms of gas. So we can outsource it to be computed in this layer, and here it should be much cheaper. Okay, so this is the standard API that we expose to contracts. And how can we achieve that? I mean, how we can reach it? So in your Inc contract, you can just call self.env. It will give you an object that implements the whole API. So for example, we can ask for the account ID that has just called this method, and we can commit we can terminate the contract, sending all our balance, the balance of the contract, to the caller. Okay, so just by this env method, we are accessing this standard API. Now, things are a bit more complicated. Well, in fact, the state transition function has like two APIs. The API for users, this is the left side, is the set of extrinsics, the things that you can call as a human, as a user. So for example, we can transfer tokens on our blockchain, we can do some staking operations, voting, we can call a contract, and every single item on this list can be expressed as a blockchain transaction and submitted to a chain, okay? This is like human API. However, the state transition function also has a second family of functions, which is dedicated only for contracts. So for example, some cryptography that can be outsourced. Some methods, some functions that bypasses some standard restrictions for human, but is safe, is okay for contracts. And some other stuff that is pretty use case specific. Humans, contracts. And in Substrate world, if you are a contract, okay, if you are a human, we can use only this list, the left side list. However, our contract code can use both of them. We can either try to act as a person, as a human, and this will be called a runtime call. So if a contract calls a runtime, the state transition function, it is called a runtime call. But in case when contract calls a special method for just contracts, it is called a chain extension. Why extension? Because we are extending the standard chain API by this method. This is chain extension. Now this is usually a bit confusing, so just for short, I've got some pictures to make it more appealing. So we've got a human Fiona and ogre Fiona, and just by making a matrix, who can get along with who, we've got two actors, right? You can be either a human or you can be a smart contract. And if you watch a movie, you are able to fill this table. Who can have a good relation with each API? Okay. The thing is, the only no thing is here. So humans cannot call contract API. These things are dedicated only for contracts. And to use technical names, if a contract calls a user API, this is called a runtime call. If it's calling a contract API, it is called a chain extension. Okay, so how does calling runtime look like? Well, it is just a sending, like we are acting as human, we are actually sending a transaction, blockchain transaction. So we have to perform two steps. Firstly, prepare a runtime call object. This is done like this. So for example, if you want to transfer a token just through runtime, we can prepare an object that represents this intention. So this is some enum variant with two arguments. And when we have this call data ready, we can just submit it to the runtime through this env object, just by saying we are calling runtime with this call object. What happens under the hood is that the state transition function will receive this call object, and it will treat it just like a plain transaction from a user. So if it was a token transfer will be performed. As simple as that. Now there's an important notice. The thing that we can call here, I mean, the part of the API, of the user API that contracts can use, is not by default enabled. Actually, the runtime developer maintainers have to explicitly say which extrinsics are safe, are okay for contracts to be called. So if we go back here, it is runtime maintainers, chain developers, that will whitelist some items on this list saying what contracts can do and what they cannot. So if you are, for example, familiar with the liquid staking process, it usually requires that staking API, staking extrinsics are available for contracts. However, as I said, this must be explicitly configured at the blockchain level, the state transition function level. Now, short advantages and disadvantages of this runtime call. So firstly, let's see the plus thing. So firstly, there's nothing new actually to be coded here. All the logic that is to be called, performed, is already there because, well, this is part of the state transition function. So all the benchmarking, error handling, everything, security, it's already there. So actually enabling some runtime calls for contracts is very easy. And the good thing is that contracts can actually mimic a user. So for example, this liquid staking, some proxying and so on, it can be done very easily. The problem is that if the API of the blockchain is changed because some indices changed or extrinsic parameters were reordered, then the contract is broken because it will try to use the old API, and things might go very, very bad. So this is it is very important that if your contract performs runtime call, it has to be upgradable so that you can catch up with the call API changes. Yeah, this is the important note is that runtime calls must be whitelisted by the chain maintainers. And the last and the saddest thing is that in Substrate, currently, extrinsics do not return any result. So if your contract calls a runtime, you will not get any value. You can, what you will get is the success, either a success or error message, but you cannot get any data. So this is unfortunately very limiting. So this is the main cause for the second API, for the contract API. Now this chain extension, meaning the special dedicated API part of the special dedicated part of the state transition function for contracts, is the way to extend the runtime possibilities, the runtime capabilities with custom functionalities for your contract. Now these things are way more complicated and complex, so that you usually do not see many chain extensions in the nature. There are a few, but preparing such extension is a pretty big challenge. So just briefly, we'll just keep how does it look on the chain side. We'll just concentrate the contract side, how working with chain extension look like. So the thing is that every chain extension, every method that is exposed, especially to contracts, is exposed with a trait. A trait that is marked with chain extension macro. Here we have some error enum that will just explain all the bad statuses. And a collection of methods that a contract can use. So for example, there is a single method called outsource that takes some bytes and returns an array of bytes. So for example, some hashing or some, no, for example, a hashing. How we can use this? Well, when we write our contract, in this inc contract macro, we have to pass a special argument, environment. Environment is some abstraction over things that we can expect from the runtime, from the state transition function. And one of them is this chain extension, this type chain extension. And this is just this trait that we've seen. So if we prepare a type, a special environment that exposes chain extension, we can use it in our contract. And once we do that, we are able to call this outsource function. Again, via this environment object, we call extension method, which implements the trait, this trait. And since it is implementing the trait, we can call this outsource function with argument, right? This is how calling a chain extension looks like. What are the advantages of this interaction? So firstly, we can prepare completely arbitrary logic dedicated to contracts. And this is, as far as I know, this is exactly what precompilers in Ethereum provide. The second thing is that we can actually perform things like a twin runtime calls, but with customized waiting for contracts, some limitations, bounding, and other stuff. Yes, we can do some proxying with it. That's not very crucial. But what's very important is that chain extensions can return values. So, for example, outsourcing things, computing things outside the contract can be done very handy in a very handy way via these chain extensions. The problem with them is that they are very hard to implement correctly and securely, and usually it's not that. As I said, there are only a few, but if there are any on production, you can be sure that they are pretty well tested, and they are really. They also have very good reason to be there. What's next? Yes, another important note is that, well, since the implementation of a chain extension happens at the runtime, at the state transition function side, it has to be maintained and implemented by the chain operators. So it is not a contract developer who is responsible for that, but instead it is the chain team who has to maintain and create the code, create and maintain the code. Just as a last thing, is that it is actually a real-life case that we encountered at LF0. We were working on some contracts that do things regarding ZK, that verify ZK proofs, snarks, whatever. The important thing is that we had to perform some very heavy mathematics within a contract. We were verifying some proofs. Unfortunately, it was extremely expensive and it took extremely long to be computed there. So what we did? What did we do? Was that using chain extension, we outsourced this heavy computation outside contract to state transition function. It was a bit better. The efficiency was okay. I mean, it was better, but not okay, not enough. Still, it was much too slow to actually work with that. So, using other techniques, other mechanisms from Substrate, we're able to outsource it even further to this outermost layer, to the node layer, which is executed natively in Rust on a bare machine, on a bare metal. And thanks to that, we've got extreme speed up. And just by returning a result from here back to the contract, we're able to perform a very heavy computation, very heavy mathematical operations in a contract, from a contract by pretty low gas usage. Yeah. So outsourcing things is very useful in some cases. And it's doable only via this chain extension. Yes, please.
So go back to the previous slide here real quick. So the actual layers themselves represent the actual closest to bare metal, basically. So the node host would be would that be closer to metal than, let's say, state transition functions?
Yes, exactly. Node is a binary that is run directly on the host machine. So whatever it does, it is. Things that are executed here are much more efficient than things that are performed here, especially that in Substrate, this state transition function is done in a single-threaded WebAssembly.
All right, so, and that's more or less just a generality, basically. Would you say a majority of node host implementations are close, or if not exactly at bare metal, or is that a sort of just a, I guess, abstract representation of how the actual blockchain works, more or less?
This approach has its own limitations.
Okay.
And the problem is that the limitations are much more general than just smart contracts. So we won't get just to the bare metal, okay? Because things has to be verified. It's another story.
Gotcha.
Sorry.
And yeah, more so, this is just, would you say this is a representation of, just throwing some shots here in regards to just my understanding. Would this represent how the layers work in regards to, like, so let's say layer 0, layer 1, layer 2?
These are completely different layers.
Okay, different content basically.
Yes, yes.
Okay.
Other layers. There's one other question behind you.
Yes. So I just wanted to clarify or have something clarified. I thought I heard you say something about precompiles, and are chain extensions basically essentially the same thing as, or a different sort of implementation as to what precompiles are? Or?
Sure. So, okay, I know very little about precompiles, but if I understand correctly, the intention of chain extensions and precompiles is that the intention is to provide a special like opcode or functionality just for contracts, so just they are more efficient. And in that case, this is the same, chain extension and precompile. Okay, because chain extension in some sense is just another opcode that is available for contracts. This is here, right? This is an opcode, and as far as I understand, as far as I know, calling a compile from a precompile from a Solidity code looks pretty similarly.
Thank you.
And the last thing is that there are plans to provide a third way, the third family of functions. I mean, the third way for contracts to interact with with its execution environment. The idea is to use XCM. This will be covered later in this in the academy. It might be the way. We'll see. For now, there are only two: these runtime calls and chain extensions, and so they already cover probably all the needs that you may have. Are there any questions for the end? Okay, so have a good afternoon.